Hi, and welcome to Android Developer Office Hours. I'm Joe Fernandez from Android Developer Relations, and this week we're going to talk about making Android applications accessible. I'm joined by guests from our Google Accessibility team. We have TV Raman to my left, Casey Burkhardt and Alan Viverette. Under the table, who you can't see, is Tilden, Raman's guide dog, who is being very fluffy and cute, but won't be speaking today. We're going to do things a little bit different today. Because we're focusing on accessibility, we're going to really just talk about those issues. Casey and Alan are going to talk about, have some material to present, and at the end we'll take some more questions on accessibility. And if you don't have accessibility questions, don't worry about it. Next week we'll make sure to cover those things as well. So with that, I'll introduce Raman.
Thank you, Joe. Welcome everyone to this session on Android accessibility. My name is TV Raman. I lead our accessibility efforts for Android and Chrome, and with me I have two engineers from my team, Casey and Alan. To give you a brief overview / intro of what we are talking about today. So as developers, when you step back and look at Android, the platform, what does Android give you? Android basically makes it easy for you to focus on your application as opposed to worrying about different devices, different screen sizes. Somebody has a keyboard, somebody doesn't have a keyboard. You focus on your application. That's really the core thing that the Android platform provides for you. And so you can write your application and have it running on hundreds of millions of different devices. What we from Accessibility do is we broaden this focus even more. So we just talked about different devices, but people are different too. Some of your users might be able to see a little less than others. Some of your users might need a slightly different color scheme. Some of them might need larger text. Some of them may not see at all and might need spoken output. Some of your users may need specific affordances. So accessibility is then about increasing and significantly increasing the size of the user base of your applications and writing applications that are really cool that work in a lot of different user scenarios. I myself work on applications that are relevant to blind users, and I describe it as working for the eyes-free user context. So don't think about the user not being able to see, think about the user not looking at the screen. So that's the broad thrust of accessibility, and what we've been working on as part of the Android accessibility effort is to build the right set of APIs into the platform so that you as a developer can focus on what you do best and what you enjoy, which is writing your application. I'll give you a brief overview of how Android accessibility works. We gave a detailed talk at Google I/O this year, and you can watch that talk in its entirety on YouTube. But essentially, Android accessibility is something we started working on in 2008 and originally shipped as part of Donut in 2009, and we've come a long way since. The typical way a blind user interacts with your application is by navigating through your app and getting spoken feedback, auditory feedback for the item that's in focus. As of Jelly Bean, we've also added Braille support that is in beta. But what happens then is that the blind user is essentially navigating your application item at a time, control at a time, getting spoken feedback. And so over the years, we've introduced better and better user level affordances for doing this. What this all looks like in Jelly Bean is that the user navigates using a combination of metaphors. One is that of touch exploration, where the user can touch different parts of the screen and hears appropriate feedback for what you're touching. And that sort of gives you random access to all parts of your display. Random access is great. It's order one complexity if you're a developer, right? You can get to anything with the same level of effort. Its problem is it's random. So what we also added in Jelly Bean was for the ability to what we call linearly navigate the interface, which then gives you a more deterministic access to different aspects of your app. And in practice, as an end user, when I use this, I use both. So I'll pull up an app, approximately know that the search button is on the top right, I'll go touch there, and if I don't hear the search button, I'll flick left or right from there and arrive at the search button and then double tap it. How all of this works in the framework is through three concepts that Casey and Alan will explain to you in a lot more detail. There is a notion called accessibility focus in the system, which is implemented alongside system focus, with the difference that everything in the user interface can get accessibility focus. And as accessibility focus moves, our accessibility services like TalkBack, SpeakIt, or BrailleBack brailles it out on a braille display. So now you have accessibility focus. As I said, when you touch, your accessibility focus lands on that spot. But you can also navigate with gestures, and Alan will show you those during the demos as we go through this, and we call those accessibility gestures. Now, we are computer scientists, and all computer scientists do things by introducing a level of indirection. And so what we do in the Android API is that the accessibility gestures actually invoke accessibility actions, and it's those actions that actually perform user actions. And this actually makes for a level of flexibility, because then in the you can actually build more innovative user interfaces for people with motor impairments and things like that, where you can then trigger these accessibility actions through other affordances. So the goal, as I said, of the accessibility API is to work behind the covers and just make your applications work. And that's pretty much true if you use built-in Android user interface controls and do everything right. But then as you step out of that box, as you start becoming inventive, as you write custom controls, then you have to give the API and the framework a little bit of help. And it's really those aspects that these next 30-40 minutes will be spent on. Alan and Casey will show you a sequence of demos and show you how these can be fixed. There is a sample app to go with this, and we can point you at the source code to this later during the talk. So Alan and Casey, take it away.
Thanks, Raman. So, as Raman mentioned, there's accessibility APIs on Android. We've had them since Donut. In Ice Cream Sandwich, we introduced the new concept, the new feature of Explore by Touch, which allows a blind user to touch the screen and have the content that's being touched spoken to them. So the way that this works is when the user actually touches a control, the Android framework takes that control, bundles it in a nice package, sends it through the accessibility API to any accessibility services that might be listening. An accessibility service is, an example of one is TalkBack. That's software that Alan and I write. We basically intercept these accessibility events that the framework sends, take the data out of them, explore the view hierarchy of an application, and provide spoken and other auditory and haptic feedback to the blind user to make the application and the device accessible. Alan actually is going to turn the device on now and show you what TalkBack looks like the first time booting up here.
All right, so one of the really great things about the accessibility service is that as a developer, you don't have to worry that much about it. So as Raman mentioned, if you use standard widgets, things just work. So we're going to turn on TalkBack first. So we're going to All Apps, Settings, and down here at the bottom we have Accessibility. And one of the services is TalkBack. So we'll turn that on. There's a switch up at the top that you can't see. So this dialog pops up explaining that TalkBack sees basically everything that is shown to the user. So all of the text that's on screen, TalkBack has access to. So we'll just click OK. It's OK that TalkBack can interact with things the way that a user would.
List showing 1 items, disabled.
So as TalkBack is turned on, you see certain items on the screen receive a yellow highlight. In Jelly Bean, this represents accessibility focus. So as Raman mentioned, accessibility focus works just like system focus, except any item, whether it's system focusable or not, can receive it, so that the accessibility service can interrogate it and find out more information about it. So as Alan moves his finger around the screen, you'll see that different items receive accessibility focus. TalkBack receives events regarding that change in focus and speaks to the user to let them know what they've touched. In Jelly Bean, there's also the concept of navigation in a linear way. So Alan can use a gesture from swiping left to right or top to bottom to move focus through the user interface.
So we'll move out to the launcher where it's a little bit more interesting. So I'll touch Home, double tap to activate it. And now I can just swipe left and right to move through items on the home screen. So I'll swipe right a couple times.
My library. Image 52.
So down here at the bottom we have all apps,
Play movies and TV. Play store.
and then one app that we're going to be using for demos later on is
Accessibility demo launcher.
So in addition to exploring by touch, you can use gestures to navigate linearly through the UI. In Jelly Bean, we've also added gestures associated with accessibility actions. So for example, Alan can do a two-part swipe up and then right, and that will perform the system action of pulling down the notification shade.
So I'll just go up right.
2:17 Wednesday, September 26, 2012 system settings. Clear all notifications. Calm. 2:18 Wednesday, September.
And then Alan can
settings.
swipe down and left, and that will dismiss the notification as if he pressed the back button.
So I'll do down and left to do a back action.
Home. Home screen 3.
So we have a couple other system gestures as well. And what's also worth mentioning is from Ice Cream Sandwich and on, accessibility services, when they receive one of these events, can interrogate the view hierarchy. So TalkBack, for example, can deep dive into the views your application presents and get more information about them, such as whether a button is clickable, a view is checkable, and so forth. So this is used throughout TalkBack. So now we're actually going to cover the top 3 problems that we see most often in third-party developer applications. We have a sample app, which we're going to use to sort of get into these issues and illustrate them for you.
Accessibility demo launcher.
And I'll double tap to launch that.
Accessibility demo launcher. List showing 6 items.
Okay, and so Casey's going to take us through the Inaccessible Content Descriptions app. So this is a very common mistake that we see.
Actually, Casey, we're getting a little rustle from your mic. Could you just make sure that it's not touching your t-shirt too much?
I think I've lost my mic. That's interesting.
You can run it up the outside of your shirt once you find it. If you
Sure. Why don't you continue?
Sure. All right, so I'll just take us through the inaccessible version of the content description app.
Content descriptions inaccessible. Content descriptions inaccessible. Edit box.
All right, so one of the first things that we see is this edit box, and there's an icon in the top left of the screen here that has a little search icon. And since I only hear edit box, I don't know that the meaning of this edit box is, so let's say, a search term. So swiping through the rest of the interface,
Go button.
that's pretty clear.
Image 76.
Now, image 76 isn't the best description for this. If you can see it, there's a little map here. So as a sighted user, I can guess, okay, this probably has something to do with location. But because there's no text attached to it, through the accessibility service, I don't know what's going on. So I'll continue to swipe through.
Image 37. Image 98.
And we have the same unlabeled images here. So let's take a step back and look at some of the ways that we can fix this. So we'll back out of the keyboard and we'll back out of
Accessibility demo launcher.
this
List
particular
showing 6
demo
items.
and open up the fixed version.
Content descriptions. Content descriptions fixed.
So
Edit
you
box.
can see in
Search for deals.
this edit box, this edit text element that we have now, there's actually hint text. And since TalkBack and other accessibility services can get information about the view hierarchy, it can pull out information from the accessibility event and from your view to learn what the hint text is. So now when I navigate
Go
to it,
edit box. Search for deals.
I hear the hint text, which gives me more context into what I'm actually doing as a user. And as I move through the user interface,
Go button.
I get the Go button, and now we've added content descriptions to these image buttons, so when I navigate to them,
Powered by local social real to medials. Local deals.
local deals,
Social deals.
social deals,
Real-time
and
deals.
real-time deals, rather than hearing image 91, image 76.
So as a developer, this is one of the easiest things that you can fix. You simply go into your layout XML, you go to each item, so you go to your image view or your image button, and you add an Android : content description. And if you have things that you specifically don't want to have a content description, you'll notice that you still get lint errors if you put no description. So you'll get these little yellow squiggles in your layout XML. So for something like there's a little star here that we're purely using as decoration. There's no reason that a user needs to know that it's a star. We simply put content description equals @null. So that @null lets it know that you've thought about whether or not your image needs a content description, and you've decided that because it's purely decorative, it's okay to be skipped. For things that have dynamic content descriptions, you can also call view.setContentDescription. So if the meaning of
Social deals.
is going to change sometime during the execution of the application, I'll simply call whatever variable I have to store that in .setContentDescription and pass it the new explanation of what that button does.
We'd also like to mention that we prefer that you would not override getContentDescription on the view class. Avoid taking that shortcut because we do some caching when setContentDescription is called, and it helps us out and make sure that your users can get the correct description of that button when they need to.
So always use setContentDescription if you're setting your content description dynamically. All right, so let's back out of this.
Back.
And one other thing to take note here is that each of these buttons is totally accessible on Ice Cream Sandwich. A lot of developers are going to be developing for, let's say, Gingerbread or below, and on these devices, accessibility relies on use of a trackball or directional pad on a hardware keyboard. So each of these buttons is also set to be Android focusable equals true, which means if a user has a keyboard and they start pressing down or right, they'll move from this icon to this icon to this icon. Buttons and image buttons are going to have this set by default. But if you use an image view, you'll have to explicitly say, this image view should be able to receive keyboard focus.
Back. Accessibility demo launcher. List showing 6 items.
All right, so let's move on to one of the next things, which is grouping and ordering of items.
Note. Content descript item grouping inaccessible. Item grouping inaccessible.
So as we move through this user interface, we see that we have some header text and we have a table with some data in it. Let's jump right into the table.
Payment processed August 2nd. Local social
And
real
you see
dimensional
as I
12 wings for the
as I
price of
navigate
6
through
at
this
the
UI,
old shop.
when I touch the
Transaction
table,
details.
I'm not actually
Credit card
getting
date,
any
August
kind of
2nd,
feedback.
2012
I have to go
status.
over and touch the
Completed
actual
amount,
item over here.
$123.45 you back.
And as I swipe left and right through the UI, I'm getting
Item grouping inaccessible.
very granular
Payment processed
information.
August 2nd. Local social real dimensionals 12 wings for
Also,
the price
if I
of
touch
6
the
at
table as a
old
whole,
wing
it's going to
shop.
read all of this
Transaction
content,
details.
which is hard to follow.
Back.
What we need to improve here is the way that the views are grouped so that the user can access the information in an individual way so they don't have to get this large burst of text.
So what TalkBack sees when you open up this application is a bunch of text. So these are all of these items here are actually just thrown into a relative layout. So date is below from, status is below date. To TalkBack, this just looks like a big bag of text views. So what it reads is a big bag of text views in order of the screen left to right, top to bottom, which is nice if you want to spend 12 minutes listening to the screen. But
Accessibility demo launcher. List
If we
showing
go into the
item
fixed
grouping
version.
fixed. Item grouping fixed.
We've now put all of these text views that are in a relative layout in their own individual groupings in a hierarchical way that makes sense. So now when I touch Explore,
From credit card.
that's exactly what I'd want to hear. One row in the table.
Local social real medials. 12 wings for the price of 6 at date. Status completed. Amount $123.45 USD.
So the user can explore each one of these rows one by one without having to hear the full text
and
of the entire table.
In our layout, what we've actually done is provide a little bit more context. So amount here is actually inside of a relative layout inside of a linear layout that contains each of these rows. And we've also, for keyboard accessibility, made this row focusable. So that lets TalkBack know that the things inside of that layout should be grouped together. One thing you'll also notice is when I go to this top bar right here, which starts out with payment processed in the top left and moves into a description of this deal at the bottom, it actually reads the title, the description, and then it reads the notes, payment processed, and the date. The reason that we've done this is because visually, this information at the top, local social real-time deals, this title is larger. It's more important, it's more immediate for the user. This description is also more immediate. If the user wants to hear more about it, they just stay on it for a little longer, they hear what the status and the date are. And the way that this actually works in code is that we've set the content description of this entire group. So we've taken this relative layout and done set content description to be the text of each of these items concatenated in the order that we want them read. So when I tap on it,
Book all social real to medials. 12 wings for the price of 6 at Ye Olde Wing Shop, August 2nd. Payment processed.
so you hear those in the order that you really want to hear them for efficiency.
Back.
Our last demo
Accessibility
here
demo
deals
launcher.
with
List showing
using
6
custom
items.
views.
Node provider inaccessible. Node provider inaccessible.
So what we have here is part of an application that is just directly drawn. We've basically implemented the onDraw method. We have several objects, and we call each of those objects onDraw. Within the context of the larger canvas, we draw it directly to the screen. When TalkBack is on, because there's no textual content actually associated with this view, it's completely dead. There's no touch exploration, there's no feedback, nothing. The application action bar will speak
Node provider
because it's a standard
inaccessible.
Android action bar, but nothing else will. The way we fix this, we have
Accessibility
APIs
demo
in
launcher.
Jelly Bean
List node provider fi- node
that allow
provider
for
fix.
developers to use custom drawn views and make them accessible. We also have a helper class available, Touch Exploration Helper, which is available on the Eyes Free website. We'll point you to the source for that shortly. And now that I've implemented this node provider, this new Jelly Bean API that allows us to define regions and custom views for things, I can touch explore the content.
Color selector. Green. Red. Yellow.
I can also double tap to make things happen.
The canvas color is now yellow disabled. Green. The canvas color is now green disabled.
And I can even do something like long
Red.
pressing.
The text color is now red disabled.
So this is basically the mechanism in Jelly Bean that allows developers to make their entirely custom drawn views accessible to the standard Jelly Bean accessibility services.
So if you're rendering something in OpenGL, which is great and pretty and fast, you can also make it totally accessible. And so this requires a little bit more work. We've made this node provider helper class to make it a little bit easier. But you can provide an entire view hierarchy virtually that TalkBack and a user of accessibility will be able to explore. So actually, I'd like to swipe through this too, just to
Color
show.
selector.
When you implement the node provider, you sort of magically get a lot of extra features. So I can swipe left and right through this,
Blue. Red. Green.
and that didn't take any extra effort. Just adding those virtual nodes lets TalkBack manage swiping left and right through the hierarchy. So one thing that we didn't mention earlier, I'd like to back out for real quick.
Accessibility demo launcher. List showing 6 items.
So you'll notice that on this tablet, everything is really small. And for somebody with low vision,
Home screen 3.
they might find that
Apps.
things in your app are a little difficult to see. So one way to get around that,
Home. Showing settings. Settings. List showing 18 items.
and I'll pop into accessibility settings,
Accessibility. Accessibility. List showing 9 items.
is to turn on a feature called large text mode.
Large text checkbox. Not checked.
So this is going to do exactly what you expect it to.
Checked. Accessibility. List showing 9 items.
So for anybody on the Hangout, or for anybody watching in maybe low resolution, you can hopefully read the text now. It's a lot bigger. And
Back. Settings. List showing 18 items.
one really easy mistake to make is in your application when you're setting your text sizes to use density-independent pixels, DIPs, instead of scaled pixels. So when you set text size, if you use scaled pixels, it respects the system's desired text size. One thing that this can be a problem for is
Home screen 1.
if you
Showing
don't
items
test your
3 and
app
5.
with slightly larger text or slightly longer strings, you may find that strings extend off the edge of the screen or wrap in ways that you don't expect. If you're doing internationalization of your apps, it's important to make sure that you're testing for this anyway. So if you have a string that shows up as a certain size, in German it may end up being longer. And with large fonts on, it's going to be longer as well as a little bit taller. So it's important to test your app with that to make sure it works. But generally, if you use scaled pixels instead of dips, this will just work. So let's go into one of the test apps real quick to see what the difference looks like.
Accessibility Demo Launcher. Accessibility Demo Launcher. List showing 6 items.
So we'll pop into the
Item grouping
inaccessible version of item grouping.
Item grouping inaccessible.
And you'll see that the text size was exactly the same. What you're really looking at here is the header. It's the same as it was previously because we've actually constructed this view using dips rather than scale pixels. And if we go back out into the fixed version, you can see that the header now is quite large, and it follows the convention of the platform by using scaled pixels, so the text is larger for users of the large text feature.
You'll also notice that the text, which used to take up only 1 line, is now wrapped onto 2. Fortunately, that doesn't mess up the rest of our view. It works very well if the line needs to wrap again. All right, so some of the other features that we're just going to cover real quick, but we're not going to do specific demos for,
Home screen 1.
are web accessibility. So Android, Ice Cream Sandwich, and Jelly Bean have support for opening web view content and touch exploring. So a lot of apps are hybrid. You have both a web view and native Android content. And if you go into accessibility options and turn on TalkBack, you should also make sure, I'll just pop in there again. Actually, I'm going to use the recent apps swipe to get in there. So we'll do down right.
5 recent apps. 5 recent apps.
I'll swipe over to settings, so that's just going to be a couple of swipes to the right.
Download. Settings.
All right, settings, and I'll double tap to open that up.
Settings. List showing 18 items.
Okay, and I'm just going to go straight to accessibility since it's
Accessibility.
easily located near the bottom.
Accessibility. List showing 9 items.
And
Enhanced web accessibility not allowed.
you'll notice this item, Enhance Web Accessibility. When I double click that, it gets a little bit more obvious.
Alert: do you want apps to install scripts from Google that make their web content more accessible? Don't allow. Do you want apps to install scripts from Google that make their web content more accessible?
So what this means is that when this feature is turned on, web views that have JavaScript are going to inject something called Android Vox. This is similar to Chrome Vox, which is our web accessibility solution on Chrome. It's basically a JavaScript screen reader. And it allows users to touch your web view content and receive touch exploration feedback the same way that they would for native Android views. This also works for swiping left and right. So if you have a hybrid web app, this feature is turned on by default when you do Setup Wizard accessibility for a new device. If you turn on TalkBack afterwards, you'll have to make sure to turn this on. So I'm just going to allow this.
Allow button. Accessibility. List showing 9 items.
And now when I have web content and I'm testing my application for accessibility, I can swipe through normal Android content, and then it'll automatically start moving into my web content when I get to that.
And our recommendation for developers who have hybrid apps or web apps are basically to use your web accessibility standards, the W3C accessibility standards, within your hybrid app web views to make sure that your content is accessible. So use ARIA live regions, label your images with alt tags, those standard web accessibility recommendations.
And the same caveats apply for alt text. So if you have decorative images, if they don't need content descriptions for native Android, they wouldn't need alt text for web content.
They do alt equals empty string, similar to what Alan said on the Android side, which is alt equal at now.
All right, so that's a quick overview of all of the features in Android accessibility. We haven't covered Braille. We don't have a Braille device with us right now to demo. But for making sure that your app works with Braille, you can actually typically just swipe through.
Service TalkBack on.
If you can swipe through and you can double-click to activate things in your app and everything is read as you would expect, then your app should work very well for a user with a Braille input-output device.
And as I mentioned, our Google I/O talk from Google I/O 2012 this year has more details on what we launched in Jelly Bean, and that also does include a Braille demo. Think of a Braille device as both an input and an output device, which is what it actually is. It's a Bluetooth device that both acts as a Braille keyboard that allows a blind user to input text and then also displays text on it. It's a fairly cool thing to see. You can look at it on the YouTube videos. But as a developer, you shouldn't have to worry about Braille versus speech, what you need to be worrying about are populating these accessibility events correctly so that these services can pick up the right information.
So as a developer, there are a lot of resources at your disposal for implementing accessibility. We have a great developer guidelines section on the Android website regarding accessibility. We have great UX guidelines regarding accessibility on the Android site. TalkBack is open source, so if you need to know a lot, you can actually check that out online. And the sample app that we ran through with bad and good versions of accessibility in applications is also open sourced and available online.
With that, I think we'll hand it back for questions.
Okay, so we actually have Richard on the Hangout. I'm going to put him on so he can ask you guys a question.
Sure.
Just give me 1 second. Richard, can you hear us? Oops, that's me.
We don't hear it, right?
One more time, sorry about that. There's a, hold on. I think
We're working on hearing you.
Yeah, give me 1 second. I'm going to sort the sound issue out real quick.
Okay. Gonna mess around a little bit with our sound equipment.
So while
Sorry, hold on a sec.
can audience hear us?
Yeah, the audience.
So yeah, while we get the audio issue sorted here, call to arms to developers. I mean, we look forward to using your apps on ever more devices with ever more user interfaces. This is fun stuff to do, and you'll probably discover in the process of making your apps more accessible that there are simple usability issues that you discover that make your app more usable for all your users as you fix these things.
I think one of the most important things in making an app accessible is making sure that it's orderly and simplified. Simplification is good for everyone. So if it doesn't take 15 button clicks to get from one place to another, everyone wins.
So eliminate the number of explicit actions that your users need to do. Eliminate the explicit pieces of content that users have to read in order to figure out how to use your application. And things that are showstoppers for your blind users are usually a pain in the neck for your average users who don't want to complain about it. But as you sort of smoothen those things out, the overall interaction gets a lot smoother. And these are mobile devices, right? These are devices we use on the go. The faster somebody can do something on your application, the more often they are likely to do it.
And the best way to test for this stuff as a developer is testing by doing. So go ahead into accessibility settings and turn on TalkBack. And go into your application and try to explore by touch. Try to swipe through your user interface.
And close your eyes and keep them closed.
Absolutely, no cheating.
All right, I think Richard's sound may be working. Richard, can you give it another shot, please? No, nothing.
Interesting.
Richard, can you do sign language? I don't know whether we can read sign language.
All right, sorry guys. I'm gonna just go ahead and read Richard's question
Sure.
now from the Hangout. Sorry about that, Richard. I'll get that question read for you. So Richard's question is, let me just scroll up. He's curious about the performance hits that a lot of the features being implemented are going to have on the device.
Yeah.
And how to get around that.
So the simple answer is there is zero performance hit. So and let me answer that in the different levels at which this actually gets turned down, and then I'll let Alan and Casey fill in. So on the Android platform, the accessibility APIs are present in every device. So any Jelly Bean device has all of these APIs. Any ice cream sandwich device has all these APIs. They are a no-op until an accessibility service is turned on. So until an accessibility service is turned on, as I said, these APIs are no-ops. When an accessibility service is turned on, these APIs raise the appropriate events and they go across binder calls. But we've spent a lot of time optimizing this in the framework. So the performance hit you see on the device, both in terms of load as well as battery, is almost zero. Text-to-speech does take up some CPU cycles, but on today's devices you don't notice.
We have a lot of developers who ask us often, is there a way we can only implement some accessibility features and turn them on if accessibility itself is on? And that's something that you can do. Through the Accessibility Manager class, there is a check to see if an accessibility service is on and if Explore by Touch is enabled.
Yeah, so if you're using the Accessibility Helper class and you're creating a virtual view hierarchy for all of your nodes, you can do this only when accessibility is turned on, and that's really easy to check. It's Accessibility Manager is enabled and is touch exploration enabled on newer devices, newer APIs. In terms of the performance hit that your application takes, as Raman mentioned, there really is none, and we care very deeply about performance. I think tens of milliseconds is really pushing it as far as the performance hit that somebody has to deal with when accessibility is turned on. So we work on profiling and making sure that we're as fast as possible.
So you should take the fact that we ship these APIs on every device as opposed to saying we'll ship it on some devices where the user asks for accessibility, should tell you that there is duplication.
Okay.
So Richard's also
Did
wondering,
sound start working yet?
especially on the battery.
Back of the envelope use, I use my device every day. It talks to me the whole time, and I don't find myself charging my phones any more often than any of these guys. So I typically leave home around 7:30 in the morning. I unplug my phone, and I typically don't need to charge my phone until about 8:30 in the evening. So, and I use my phone a lot.
I also use my phone a lot. I think I may actually get worse battery time than Raman because I have my screen brightness set a lot higher. So I think that's actually one of the most interesting things, is that while we are doing speech in the background, we're doing vibration in the background, if the user just turns their brightness down, they're probably going to save more battery than they're eating up from the vibration, the haptic feedback.
Alan wrote me a wonderful application called Shapes that actually makes my screen go completely dark too, which is a total winner.
Yeah, so on an OLED device, he's saving a lot of battery on screen brightness.
I do that on my laptops too. My little laptop gives me about six to 8 hours. So. It's a good thing. Turn your monitor off, use speech.
It's a challenge for the rest of us today, I suppose. Try turning your monitors off.
Oh.
On the computer without them.
The other one was adjusting the voice.
This is from the Hangout? We should have, no? Okay. Let's see. I actually thought I'd ask you guys a question. We mentioned accessibility for web views, and that feature is now in Ice Cream Sandwich and also in Jelly Bean. What's your advice for folks who want to try to support that for releases prior to Ice Cream Sandwich and 4?
So actually the web view access was also there in Honeycomb, which is beside the point. So if you're looking at gingerbread devices, if you have an application that's a hybrid application and you want to support accessibility for web views, you could do what our Gmail team did. And what they did was to take the ChromeVox code base. So ChromeVox, as Alan explained, is a JavaScript screen reader. It's an accessibility tool written entirely in JavaScript. And what happens in Ice Cream Sandwich, Honeycomb, Ice Cream Sandwich, and above, is that the Android framework, when accessibility is enabled and that option is turned on, it actually adds a little piece of code that injects that script into every web page. So the script is downloaded once, cached on your device, and then injected into HTML pages as they load by adding a script tag. So if you have a specific application, as in our case Gmail, what the Gmail team did was, going all the way back to Froyo, they took our script and added a little piece of code in their web view handler that on load basically added a script tag that injected a script, and then that's actually how Gmail talks on both Froyo and Gingerbread. So if you are a developer who's got a hybrid app and you want to support all the way back to Froyo, there's a way to do it.
So if you're looking into doing this yourself, you can actually check out the WebView source code on the Android project site. Look for accessibility, and you'll find all of the places where we're getting the URL for the accessibility script, injecting it, providing a Java bridge API to JavaScript, and you can add that to your own web view, being careful to not turn that on Honeycomb and above because it's already being injected. You don't want it twice.
And once you do that, the servers that are serving that script up have a caching policy set appropriately, so you just need to invoke it and then not worry about it. Between the device and server, they'll negotiate appropriately and get the script every few weeks based on the caching policy. So you don't have to worry about taking a download hit on each access.
And also, if you're concerned about performance hits around the injection, you can again check Accessibility Manager to see if an accessibility service is active on the device.
Yeah, that's super important. You don't want to inject the script if accessibility is off, because then everybody will get touch exploration and it will talk, and that will be weird.
Great. Thanks for that very comprehensive answer, guys. Do you have any more questions from the Hangout?
Yeah, Richard also wants to know if there's a way to change the voice parameters. I think he's referring to maybe using a different voice. I'm just waiting for confirmation.
Different voices.
This is my favorite thing about Android.
So you want to answer that, Alan? Go for it.
Sure, I think we've all sort of had an experience with this. So I personally use an Australian voice on my phone, a female Australian voice. It sounds really great for driving directions. But one of the cool things about Android is anyone can write a text-to-speech engine. So if you go on the Play Store, look for text-to-speech, there are a lot of engines that you can download for like $3 or $4, and you get great quality voices. These are drop-in replacements. So if somebody installs a German voice and their device locale is set to German, it will just speak. It will speak everything in German correctly. We have translations in TalkBack for all of the languages that are available for TTS on Android.
And also, as far as changing voice parameters, TalkBack will respect whatever is currently set in text-to-speech settings. So if you prefer voice faster, you can set the voice speed to very fast. TalkBack will use that and send all the device feedback in a very fast manner.
So for us, when we designed the Android text-to-speech API, we had a couple of guiding principles, which is we wanted users to be able to get better voices and have all their talking applications talk with that better voice, both TalkBack or other applications, right? So let's say somebody's written you an app that reads a book. You get a better voice. As a user, you should be able to use that voice for that other app. So voices and apps are not tied. And that actually creates for a good ecosystem, because if you're a developer who's writing an application that talks, you can focus on writing your application and be assured that when a user gets a better voice, your app sounds better. Right? Just as if I download your app, if I buy your app today and then I use it on a phone with a better display, it looks better. Right? So similarly, if I download your app today and I get a voice that sounds better, your app.
Did you hear that?
And that's actually how this whole thing is built. So thanks for the question. And shows up another aspect of the platform that's interesting.
There's a couple of YouTube streams.
Questions in the YouTube stream, which I'm not sure I can find. Maybe you can read them out for us, Daniel.
Yeah, so the one I found is from Funnergoat. His question is, any tips regarding accessibility and app widgets? What type of app widgets do target users get the most use out of?
So speaking for myself as a user, app widgets that display a succinct piece of information are really, really useful. So I'll highlight both app widgets that I find useful and app widgets that I don't find useful. This is not necessarily a criticism of those widgets, but more a user's point of view of what works in the IS3 world. So something like a finance stock widget that you basically touch and it speaks the current stock price is enormously useful, right? It saves you that effort of context switching and going to that app and looking for that thing. Clock widget obviously speaks the time, you don't have to launch the thing, great stuff. I actually find the Gmail widget very useful. So I actually have on my home screen a Gmail widget that shows me a particular label. And in my environment, I've actually got set up where, as summarizing the widget, it actually speaks the snippets of all the top email messages in that widget. It's really nice because one touch, you hear it, you tap it, you launch it. Widgets that are not that useful. So widget that shows you the 7 books you have on your bookshelf by showing you a little pixelated image of the spine of the book, not useful, right? Because the thing is, if you sort of do an accessible, speakable version of that, where you touch it and it speaks the titles of the 7 books, you might as well launch the thing and go look at it there, right? So on the other hand, a widget that directly launches a book is very useful, because that's like, you're reading a book, you're in the process of reading it, you've paused reading it, maybe it's a book you're reading over 3 weeks. Having a widget to that book on your home screen is really useful. So yeah, so app widgets are weather widgets are actually absolutely useful, because again, you just want to know what it is without launching the app.
So from like a coding perspective, do you guys have any information about how that should be done? Is it the same basically?
Yeah,
Same.
it's the same deal. Add content descriptions. Always make sure that you have content descriptions. Always test your apps with accessibility turned on, and your eyes closed, because you'll find out a lot of shortcomings.
All right, great. Any more questions? I don't see anything here.
Yeah, I'm gonna put Richard back on. We actually have sound now. I was able to debug, so
Awesome.
Welcome back.
Hello, Richard.
How you doing, sir?
Good.
Good, thank you.
Good. I'm on a Mac too. I restarted my browser, so that helped. So I was kind of curious about anytime a feature comes out. I work for a company in Milpitas, and what we do is certification programs. So my job's Android full-time, and my job is to be aware of these features, run the development crew, and what we're doing, particularly interested in, are like the certification that goes around the device. So you implement the feature, goes to the carrier or the OEM, they implement the feature. What do you make them do to show that the feature is working properly?
So there are CTS tests that test accessibility along with other parts of the platform. So
Did you say CTS tests?
CTS, yes.
Right, it's the compatibility test suite is that acronym if you need a translation there.
Right.
No, that's fine. I just haven't seen that particular test suite yet.
Okay, yeah, you need to go check out the source.android.com site and look under the compatibility tab. You'll find the information about that.
Okay, so you do have your test suite out there. I've got all the code, of course, and I'll just go ahead and take a look down in there and see what you folks are doing. Because one of the things that I have to deal with too is when an arbitrary person writes an app and they're using it, I have to be able to tell them whether or not they've done it right.
Right. So we don't have tests for those today. What the CTS tests do is they test what you asked before, which is, a carrier or a device provider has taken Android and they've implemented it on their device. How do they know that their platform is compliant? And that's what the CTS tests do. And as part of that, we also test for accessibility compliance to make sure that accessibility on the platform doesn't break.
Okay,
Right.
perfect. Those are very useful, by the way, throughout the platform. Thank you so much for putting those out there. It's it literally allows me to do my job.
Do good, useful things with it. That's why we put it out there.
Oh, absolutely. The hard part I have is getting through all the code. I spend so much time just going through the code and making adjustments. I wish I had more time to actually put back in. In fact, today I just signed the contributor agreement for Google after all these years. So hopefully you'll be seeing some things. But yeah, it's a lot of code to go through.
No doubt. Great. Well, we're glad to have you as a contributor and keep asking us questions and contributing to the site. We really appreciate it.
And to keep you busy, we are writing more codes.
That's good. I know. Well, part of the challenge with picking a contribution to work on is how do I not duplicate what's already been done? Because I don't know what someone's doing at 2 a.m.
There's no way to know.
No, there isn't. So that's part of
You can just do it and hope you're doing it better.
That's right.
Pick the thing you like to do the most and do that.
And you'll probably
That's a
do
good
it
rule to
well.
follow by my understanding.
I'm doing a lot of virtual machine work right now, and down in the guts of Dalvik right now. And so, what I'll be looking for is, how does the virtual machine handle the talkback? Because there's a native interface, I assume.
Oh, this is actually a great time to mention that if you turn on TalkBack on the emulator, It just works. So the emulator has text-to-speech. You may need to install TalkBack. Is TalkBack built into the emulator now?
I don't know.
You may need to install TalkBack separately. That's available also on the ICE3 project site that we mentioned, where the source code for TalkBack is. But if you turn on, you can use touch exploration by moving your mouse around the screen. You can basically, actually that's a great way to test keyboard accessibility. So you've got a desktop with a keyboard, you open up the emulator, and you can use the arrow keys to move through your application. And that works the same way that a hardware keyboard would on a device like the Droid.
Alan just mentioned moving the mouse. Let me reiterate that. The way touch exploration is implemented on Android is using what we call the on-hover pipeline. And so when you move your mouse, that generates hover enter and hover exited events. And that's actually what the finger is generating when you're doing touch exploration. So
okay. So what part of the OS handles the event, the actual event? Is that's done on the main thread, or are you passing it off to some other service?
That's probably a little deeper than we can go right now.
So I can go into a 30-minute explanation of
that's fine.
the input
It's
subsystem.
done by looking at the source code. The other closing thought, if you're playing with an emulator, or if you're you can also play with Bluetooth keyboards. I actually have a little pocket-sized Bluetooth keyboard that I sometimes use, and that keyboard actually has a little touchpad that acts as a mouse, and you can actually do touch exploration using the things. It's actually pretty cool. You can leave your phone in your pocket and hold this keyboard, and touch explore your phone. It's very interesting.
I'll go down and look at the code. That'll probably answer my question.
That's good. Yes, absolutely.
great.
Thank you, Richard.
All right.
You're welcome. Thank you very much.
Great, yeah, thanks for joining us. We're just about out of time, so we're going to wrap up. Thanks to Alan, Casey, and Raman today for joining me and telling us all about how to make our applications accessible. We'll be posting those resources that we mentioned, the project, the application and code that they were demonstrating today, which includes the helper class for accessibility, correct?
That's right.
And so take a look for that on our Google Plus stream. And that's it for today. We'll be here again next week to take our general questions around Android development. So thanks for joining us. We'll see you next week.